This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Ms. Patricia or Ms. Stella will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. Hope everyone is having an awesome day. If you are here for Math 1324, they have put a link in the chat so that you can go to a separate room. And for those of you in 1314, you'll stay here in this room. So today, we're going to be looking at the standard form of quadratic equations and graphing. And so for chapter 2, this is the beginning of chapter 2 if you are taking Math 1314. Okay, so we'll get familiar with our quadratic function. I know in section 1.6 you were introduced to this function, and in this section we're going to get really deep into it and then go from there. So a quadratic function, remember, is a function that has the highest degree of the variable is going to be a 2. And so your quadratic function will look like this. And the graph is going to be a U-shaped graph, and we call it a parabola. So here's an example of that. And then the f of x equals x squared, we call that the parent function. And so later on in this chapter, you're going to see polynomials that have degree 3, 4, 5, and so on. And we call those polynomial functions. So let's look at the quadratic function a little bit closer. So if a function is written in this form here, we call that the general form. And if a function is written as f of x equals a x minus h squared plus k, we call that the standard form. And so here we have two examples. One is f of x equals x squared, and one is f of x equals negative x squared. As you can see from the graph, one is opening up and one is opening down. So let's see what causes that to happen. So if you compare the two functions, what would be your guess that caused one to open up and one to open down? So you can put it in the chat if you want to take a shot at it. Okay, so what is the difference between this function and this function? And so we'll look at that in our next slide. So if you said to yourself that the negative was the only difference between this function and this one, yes, the number in front of the x squared is going to make a function either open up or open down. So if a is greater than 0, and remember a is going to be your coefficient in front of x squared, if it's greater than 0, then the function is always going to open upward. But if it's less than 0, then the graph will open downward. At any time, if you have any questions, feel free to raise your hand or type it in the chat so that we could address it. Okay, so these parabolas also have some special points that we like to highlight here. So the lowest part of our parabola, we call that the vertex. And the vertex can actually be found using this formula here, or it can be found from taking it from the standard form. Yes, I can do that. So let me go back to the definition here. And so here's our definition. And so A, B, and C, these are all real numbers. And A cannot be 0, because if A is 0, then all of this term here would be gone, and then you would be left with a line. At any point also, if you would like to download this presentation, if you can see my blue mouse here, right above it, you should see a little box with an arrow pointing down. If you click on that, it's going to allow you to download the whole presentation. Okay, so let me go back to number 5. There we are. Okay, so the bottom part of the parabola here we say is the vertex, but we also call it the minimum. So in this section, if they ever ask you to find the minimum point and your equation is a quadratic equation, then they are referring to the vertex. Or they could also ask for the maximum point, and the maximum point is also the highest part of your parabola. And so if a question says find the maximum point, they're referring to the vertex and specifically the y value. Okay. So if your equation is in standard form, like I have here, then you can easily get your vertex. And so here we have a minus h. So the x coordinate is going to be a positive h. So notice it's going to be the opposite. And then the value of k, it remains the same. The reason it becomes the opposite is, if you remember in the first chapter, whenever you have x minus a number, this is a transformation that sends your graph to the right. So if we were to move our graph to the right, then that's why the vertex there would be a positive h. Okay, so and we're going to do more examples on that here in a second. Now, each parabola has a axis of symmetry, and the axis of symmetry is just a line that cuts the parabola in half, and I've represented it here with the green dotted line. And the axis of symmetry is always going to be that x coordinate of your vertex. In this case, the negative b over 2a if you're using the vertex formula, or in this case, x is equal to h. So either way, if you remember that it's always the x coordinate of the vertex, then that is going to be your axis of symmetry.
Yvette, I'm sorry. Can
Yes?
you go back to the definition of the quadratic function, please, for us?
Sure. Let me go back. Okay. Was there a specific question on that one?
I had a student on the chat that said that wanted to just go over the first slide again, the definition of the quadratic function.
Okay.
Thank you.
Yes, so here you can see the definition is here, and A, B, and C are your real numbers, and so we call those coefficients, okay? And you know it's going to be quadratic if the highest power of your variable is a 2, and so that's going to be your quadratic equation. Okay, let me go back, and I think I was here. Okay, so now that we have looked at what the graph of the quadratic functions looks like, we're going to go into a little bit more detail on graphing them and then converting the general form. So we call this the general form of a quadratic equation. And we're going to want to convert it so that it looks like the standard form. And one of the purposes of converting it to standard form is so that we can easily get the vertex out of it. And so you'll see here in the next few slides that I'm going to do, I think it's like 3 examples on how to convert from one form to the other. So when you're doing your assignments on WebAssign, some of the questions will ask you to convert. And so hopefully with our examples here, you'll be ready to answer those questions there. Okay, so the method that we're going to use to convert the general form to a standard form is completing the square. And so I'm going to break it up into different steps. So the first example might seem like it's a lot of steps or it's taking long, but it's only because I want to make sure that we write down each of the steps and we see exactly what's happening. And then by the third example, you'll see that it goes a little bit quicker. Okay, so the first step, at least for my students, I tell them to group the x terms together. So here I have a 4x squared and an 8x. So I'm going to group those together, and it's going to look something like this. So 4x squared plus 8x. And then I actually ask them to leave a little space after the 8x before they put the parentheses. So here I haven't changed the problem. I'm only just rewriting it to look a little different. The second step is, or even here in the first step, it says to factor out any coefficient of x squared. So in front of x squared, the number in front of x squared should always be a 1 when completing the square. And so if you look at this example, I have a 4. So we're going to need to factor that number out. Okay, so if I factor out, if I look at 4 and 8, their greatest common factor there is going to be a 4. Now, sometimes if you struggle with the factoring, then what's really happening is we're dividing this number by 4 and we're dividing this number by 4. So when you factor it out, 4 divided by 4 just became x squared, and 8 divided by 4 is going to become, let me go to the next slide, 2. Okay, so let me repeat that. So my greatest common factor was 4. So if I divide this 4 by 4, I get a 1. If I divide 8 by 4, I get a 2. Okay, so now the number in front of x squared is a 1, which is what we need to have. So in front of x squared, we have a 1. So we can go to step 2. So for step 2, we're going to take half of b. And remember that for b, it's always going to be the number that's in front of the x term. So here I have my x term. The number in front of that is a 2. So if we take half of 2, we're dividing by 2. So 2 divided by 2 gives me a 1. Okay, so that is your second step. Take half of b. Once you take half of b, then we're going to square it. So 1 squared is going to be equal to 1. And so that completes your step 2. So we can go on to step 3. Once you square it, so I'm taking my squared here, which was 1. We're going to add and subtract it inside of this parentheses. Okay, so I have x squared plus 2x. I'm going to add my 1 and I'm going to subtract my 1. And so it might seem silly right now, right? It might seem silly right now that we're adding and subtracting, but it's going to make sense in a little bit. Okay, so step 2 was take the number in front of x, take half of it, so we're dividing by 2. So when you take half of 2, you get 1, and then we're going to square it. So 1 squared is going to be 1. Okay, so then we add it and we subtract it. So now what's going to happen is, we're going to want to get rid of this negative 1. But Ms. Chuka, you just put it in there and now you want to take it out. The reason we had to put it in here is because 1 minus 1 is 0. So we're essentially just adding 0 to this problem so that we don't change the problem. That's the reason it was important for us to include that negative 1. So we're going to take this negative 1 out of the parentheses. Notice what's going to happen here. If I bring this negative 1 out, it's trapped in this parentheses, right? So anything that is outside of the parentheses, the 4 is being multiplied to each of these terms. So if I'm going to bring it out, it's going to be important that I multiply my 4 that's in front times my negative 1, and that gives me a negative 4. Okay, so now this negative 4, since we want it out of the parentheses, I'm just going to add it to my constant 16. Okay, so let me repeat that. So if I bring this negative 1 outside, I always have to multiply by whatever I have in front of the parentheses. So 4 times negative 1 gives me a negative 4. Now this negative 4, I'm going to go ahead and add it to my constant term here, 16. So 16 minus 4 gives me the 12. So it doesn't look like we have made progress as far as writing it in standard form, but notice what happens now. X squared plus 2x plus 1. This is a perfect square, so we can actually factor this out. And when you factor, notice what happens. We're going to have 2 parentheses, right? Because 1 is 1 times 1. X squared is x times x. And if we add 1x plus 1x, we get our 2x. So now notice that I have an x plus 1 and an x plus 1. So I have 2 identical factors here. So I can rewrite them as just one factor with the square by squaring it. So I have 4 times x plus 1 squared plus 12, which is now the standard form. So let me just highlight something. So this number here that you have in the parentheses, this 1 and this 1, there is a shortcut to determine what number should be. Okay, so let me go back and tell you what that shortcut is. So if you remember, when we took half of our number, I guess it's right here. After you take half of your number, then that's going to be what you put in the parentheses over here at the end. And you'll start to notice that pattern once we start doing the other examples. I'll highlight it again. Okay, so why do we want it to be in this form? So with it being in this form, we can actually take the vertex. And so we'll do that on our next one. So we have 4x plus 1 squared plus 12. What is going to be my vertex here? Okay, so let me put the standard form. So this is just a general one. The vertex is given by h and k. But notice that instead of a negative h, we're writing the positive h, and then we're keeping the sign of k. So what do you guys think our vertex is going to be for 4x plus 1 squared plus 12? Any guesses? What is our k? Our k seems to always be like the easier one, right? And then our h is going to be -1. So Mr. Fuentes says -1 and 12. And so that's going to be correct. So it's the opposite of what you see here, +1. The opposite of that is -1. And then the 12 stays the same sign. Okay. So don't worry. We have 2 more examples of completing the square. And that way we can get used to completing the square. So here's another example, right? So your first step is to factor out anything that is in front of x squared that is not a 1. So in our problem, we have x squared plus 2x plus 1. So in front of it, I already have a 1, so I don't need anything else. So I'm going to go ahead and separate my x squared and my 2x. And notice that little gap that I left here. And that's because that's where I'm going to be adding and subtracting that same value. And then I have my +1. Okay. So step 1 was pretty easy in this situation because we don't have a number in front of x squared. So step 2, identify b. b is this number in front of x, in this case 2. I'm going to go ahead and take half of it. So 2 divided by 2 is 1. So that's a half of 2. And then we have to square it. So 1 squared is equal to 1. Is there any questions on step 1 and step 2? Okay. So now that we have our number that's squared, then we're going to go to the next step, which is to add it to the parentheses, but we're also going to subtract it. Okay. And now we don't want that negative in there, so we're going to have to pull it out. So I'm going to go ahead and take it out, factor it out. But remember, when you factor it out, you have to make sure that there's nothing in front over here. So the number that's over here is a 1, right? So if I bring my 1 and I bring my -1 down, 1 times -1 is just going to be -1. So I can write it in here, -1. So we'll continue. So 1 plus a -1 is going to be 0. Okay. And now what's left in here is going to be my parentheses, x plus 1 times x plus 1. So again, if you factor this out, 2 numbers that you multiply to give you 1 is 1 and 1. And if you add them, it'll give you a 2. Okay. And notice that shortcut, after I took the half, I got a 1. And that's what I'm using here. Okay. So now I have f of x is equal to x plus 1 squared. And that's going to be your standard form. So in this situation, what would be our vertex? Any guesses? -1 for, since I have my +1 here, remember it's the opposite. So that's going to be a -1. And then I don't have a constant number here. So that k is going to be 0. Okay. So the axis of symmetry is that it's that dotted line that cuts the parabola in half. And remember that the axis of symmetry is always the x value of your vertex. So in this case, we write the axis of symmetry as x equals -1. Okay, let's try one more. That is, I think I actually have two more, but let's go ahead and try this one. So again, we separate it, right? My x terms. And do I have a number in front of x squared? I sure do. So I need to get rid of that 2. And the way we're going to get rid of it is we're going to factor it out. So 2 divided by 2 is 1, so that's my x squared. And 8 divided by 2 is 4, so that's my 4x. If you're not sure, you can just double check. 2 times x squared is 2x squared. 2 times 4 is 8x. Okay. So now we can identify b. B is 4, so I'm going to take half of 4. So half of 4 is going to be 2. And my next step is going to be to square it. So I'm going to take my 2, I'm going to square it, and I get 4. Okay, so what do I need to do next? We need to add it, the 4, and subtract the 4 in the parentheses. And now this -4, I don't want it to be in the parentheses. So I need to take it out. I need to factor it out. So this -4, if I bring it down, there's a 2 in front. So 2 times the -4 is going to give me that -8. Okay. So again, any number that's in front, you want to multiply it before bringing it out. So 2 times -4 gives us our -8. So if we simplify, x squared plus 4x plus 4, two numbers that I can multiply to give me 4 are 2 times 2. And notice my signs are positive, so both would be positive. And here you could see the shortcut a little bit easier, right? So when you take the half of 4, you get a 2. So you have a +2 and a +2. So that's your shortcut here. If I rewrite it, then this is my standard form. And my vertex would be a -2 and a -1 with our axis of symmetry as x equals -2. So those were pretty simple, right? So let's look at one where, okay, maybe it wasn't that one. So let's try this one. Okay, so I'm gonna give you like 30 seconds so that in your mind or on a piece of paper, you can think about what your first step is and maybe try your second step. Okay, and then I'll go ahead and continue. So that way, you're at least trying to see what the process is, and instead of me just telling you right away. Okay, so hopefully you had a chance to think about what would you do first. Okay, so the first thing is separate it, right? So here I have my x squared and my x. So that's my first step. My second step is I want to factor this 5 out. I mean, the greatest common factor of 5 and 15 is going to be 5. So if I factor out of 5, then I'm going to end up with 5 parentheses x squared plus 3x. And why? Because 5 divided by 5 is 1, and 15 divided by 5 is 3. And so we're there. Okay, so now I need to find my b. So my b is going to be 3. And I need to take half of 3. So before we had some pretty nice even numbers, right? So half of 4 was 2, half of 2 was 1, but now we have a 3. So half of 3 is 1.5, right? So I'm going to leave it as a fraction just for now. So 3 divided by 2, that gives me the half. And then I have to square it. So if you square 1.5, you can square that or leave it as a fraction. So 3/2 squared is 9/4. So that's still okay. Now I need to add this 9/4 and subtract it in the parentheses. So I have 9/4 minus 9/4. Okay, so far it's still looking good. It's still the same process, right? So we want this 9/4 though. We want to bring it outside. But once I bring it outside, I'm going to have to multiply by what? The 5 that's on the outside. So let's see, let's do that. And I've done the work on the right side over here. So this negative 9/4, we're going to multiply it times 5. So we get 9 times 5 is 45, and 4 times 1 is 4. So we end up with negative 45/4. And so this number, we're going to be adding it to the 5. Okay. So again, just to clarify, let me go ahead and circle something here. So we took this number and this number, and we're multiplying. So I'll put an X for multiplication, and we ended up with 45/4. Okay. So that negative 45, I went ahead and put it here next to our constant negative 5. So if we simplify, in order for me to add negative 5 and negative 45/4, I need a common denominator. So I'm going to have a 4. So 5 times 4 is 20. And I end up with 20/4 and negative 45/4. But notice what's happening on this side. So if you wanted to factor x squared plus 3x plus 9/4, you would have to find two numbers that you multiply to get 9/4. And that might not seem as easy as the other ones we did. And this is where the shortcut will come into play, right? So the shortcut was you take the number, which is 3, and you take half of it. So that's 3/2. So that number is what goes in the parentheses, 3/2. Okay, so that is the shortcut in case you end up with like a really weird number that you have to try to factor. Okay, so let's simplify further. So x plus 3 squared, I can write it as x plus 3 squared here. And then 20 minus 45 is negative 65. So my vertex would be a negative 3/2 and a 65 over 4, negative 65 over 4. So our axis of symmetry is our x coordinate, negative 3/2. Okay, so those were a couple of examples using completing the square. Again, you'll be able to watch this video again in case you want to see the step-by-steps again. And they'll provide a link for you on where to find the video. Or you can download the slides. All right, so we're still in the same topic, but now it's a little bit different. It says write the standard form of the quadratic function whose graph you're given. Okay, so here we want to find the equation, and they give us this graph. So I always tell my students, it says to write the standard form. So it would be a good idea to write down what the standard form is so that you can visualize what you're trying to get to. Okay, so eventually the equation we come up with is going to look like this. And just a review here, your vertex is your h and your k. So in order to write the standard form from a graph, you need the standard form, and then you need at least 1 point. So if we look at our graph, you need the vertex is right here, and you need one additional point. You want to pick a point that you know for sure. So for example, I don't want to pick this point here because I don't know what the actual value of that point is, but I could use 0, 0, or I could use negative 2, 0. Okay, so for this example, we're going to go ahead and use our vertex, negative 1, and our point 0, 0. So what we're going to do with these 2 points is we're going to plug them in to the standard form. So I'm going to write down my equation. And so I have f of x. Remember that f of x is y. So in my given point, my y here is 0. So I put in 0 is equal to a. I don't know what a is right now. And then x comes from your additional point. X is 0. So I put in a 0. And then we have our h. Well, our h is negative 1. That's our vertex. So I'm going to have minus negative 1. And then our k is negative 1. Okay, so if I simplify, then I have 0 is equal to negative is a positive 1 squared minus 1. a times 1 is just a, right? And then I'm going to take my -1 and I'm going to add it to the right side. So +1 here, +1 here gives me 1 is equal to a times 1. Well, if I divide by 1, I just get 1. So a is equal to 1. So I solved for a, but that's not what the question said, right? The question said to find the standard form. But at least I know what a is. So now I can use my a, I can use my vertex so that I can write my standard form. Okay, so here's my a, and I entered my vertex, and then I simplify. So negative negative is a +1, and then we have 1 times all this is just itself. And so this would be our answer. F of x equals x plus 1 squared minus 1. Okay, so I have another one so we can make sure we get it. So the only difference here is that they don't give you this graph, but they give you the information that you need. So which is you need the vertex and you need a point. So our case here, our point is 0, 3. So if I want to write it in standard form, I write down my standard form equation, and I'm going to plug in these values. So I know this is h, I know this is k, and I know that this is my x, and this is my y. So I'm going to plug in these 4 values into this equation. So f of x is my y, so I'm going to plug in a 3. And then I have a, I don't know what a is. X is 0, so I plug in 0. And then my h, 3, and my k is -15. So we're going to simplify. So negative negative is a +3. And so 0 plus 3 is 3. 3 squared is 9. So we're at 3 equals a9 minus 15. We're going to add 15 on both sides. So plus 15 and -15 is 0. And 3 plus 15 is 18. So we have 18 is equal to a9. Divide by 9 on both sides. So we get a is 2. So now we can take our information and plug it in. So my a is 2. I plugged in my vertex and simplified. So my answer is f of x equals 2 times x plus 3 squared minus 15. Okay. Any questions on that last slide? All right, so just switching, it's still quadratics, but switching a little different here. We want to find the zeros, okay? So the zeros are these x-intercepts. And remember, they have 4 different names. So if you see some questions that say find the solutions, they're still looking for that point. Find the roots, they're looking for that same point. Okay, most of the time in this chapter, they are going to refer to them as zeros and sometimes x-intercepts and sometimes solutions, but the most is zeros. Now to find these points, we always let y equal 0 and we solve for x. So in this section 2.1, most of these are quadratic equations. So here's just a few ways that you can solve a quadratic equation. You have a square root property. The only thing with that is you can't always use it. It depends on your function. You can use factoring, but factoring doesn't always work. So, I always tell my students, give yourself 20 seconds. If you can't figure out the factors, then move on to a different method because maybe it's non-factorable. And then the last method, quadratic formula, that one you can always use. The only problem with that one is that it's easier to make a arithmetic mistake, but that one works for everything. And then also something to consider is that not all quadratics will have x-intercepts, okay? So we're gonna just go over some of these briefly. So we have the square root property. If you only have an x squared term, but you don't have an x, then you can use the square root property. To use it, again, first, we would have to let f of x equal 0. I'm going to add 4 on both sides, so we get 4 equals x squared. Then we can take the square root, and we end up with x is equal to plus or minus 2. So these are going to be your zeros. Now, just something to highlight here. The only reason we could use this square root property is because the coefficient in front of x squared is a 1. If it's not a 1, then we have to make it a 1. Okay. So if you look at the second one, f of x is equal to 3 times x minus 4 squared minus 27. My first step, I let f of x equal 0. Then I want to isolate my x squared term. So I'm going to add 27 on both sides. So plus 27 plus 27, 7 equals 3 times x minus 4 squared. So this 3 in front, we need to get rid of the 3. So I'm going to divide by 3 on both sides. So 3 divided by 3 is 1. 27 divided by 3 is 9. Now my x minus 4 squared, my x term, is isolated, so I can take the square root on both sides. Okay, the square root here and the 2 is going to become 1. A lot of people say they cancel. If that works for you, then that's fine. But in reality, it becomes a 1. So it becomes a power of 1. So the square root of 9 is plus or minus 3. And then the square root of x minus 4 squared will become x minus 4. So now we're going to add 4 on both sides. So we end up with 4 plus or minus 3 is equal to x. So how do we read this here? It's going to give us two solutions. So one solution is x equals 4 plus 3 is equal to 7. And the second one is 4 minus 3 is equal to 1. So these are our two solutions. Okay, let's try one where you can factor. So here, if you notice, there's no way that I could use the square root property. And the reason is because you have the extra x here. So we have to use a different method, which we're going to try factoring. But your first step is to make the y equal to 0. So two numbers that you can multiply to give you a negative 6 is 3 times 2. And the sign is negative, so that means your signs have to be different. And your bigger number should have that negative so that we get the negative 1. If you struggle with factoring, if you look at our 2 sessions ago, we did a whole session on factoring. And so you can go to the recorded sessions and review the factor there as well. Okay, so once you have your two factors, that shouldn't say 0 at the end. So let me cross it out. Okay, so just ignore this part. Okay, so once you have your two factors here, you can set them equal to 0, each of them. So x minus 3 equals 0, x plus 2 equals 0, and these would be our solutions. Okay. And then the last method is to use a quadratic formula. And I wrote the quadratic formula on the right side here. Okay, so the first thing you should do is identify what your a value is, your b value is, and your c value is. And so a, b, and c are going to be, a is always the number in front of x squared, b is always the number in front of x, and c is your constant. And when I say always, that's true if it's already written in general form. If it's not in general form, then you have to make sure that it looks in general form before you can identify your a, b, and c. So in our example, a is 1, b is negative 2, and c is negative 8. So we're going to substitute those values into our equation. So I have negative b, which is negative plus or minus the square root of negative 2 squared minus 4 times 1. And then our c is negative 8 divided by 2 times a is 1. So if we simplify, negative 2 squared is 4. Negative 4 times 1 is negative 4 times negative 8, positive 32. 4 plus 32 is 36. And the square root of 36 is 6. So now we're left with this, right? So I can divide 2 divided by 2 is 1. 6 divided by 2 is 3. So now I just have x is equal to 1 plus or minus 3. So I can separate it as x equals 1 plus 3 equals 4, and x equals 1 minus 3, which is negative 2. So these would be my solutions. Okay, so in so these were the different methods. We're gonna be using this methods, especially like in 2.5, we're gonna be using these again. So I do encourage you, if you want to, if you're struggling with factoring, go ahead and watch our recorded video on factoring, or you can always stick to the quadratic formula. There's nothing wrong with that either. Okay, so now let's look at a couple of things from 2.2. Okay, so the first thing is just what is a polynomial? Okay, so you're gonna hear this word quite a bit. So a polynomial is a continuous graph. So that means that you could draw the graph without lifting up your pencil. If you at any point have to lift it up to draw another part of the graph, then it's no longer a polynomial. Okay. A polynomial is also a function that is smooth, like this is smooth, and it has no sharp turns. So this one has a sharp turn, therefore it's not a polynomial. And so the first thing, what you're going to see in these sections in chapter 2 is that in each section, you're going to be finding different things about a graph. And then at the end, you're going to take all these different things. You're going to find all these different things. And give me a second, real quick. You're going to find these different things. And then you're going to be able to draw the entire graph. Okay. So here you have 4 graphs. And our first term is going to be to find the leading coefficient. Or we're going to be doing the leading coefficient test. And I always tell my students, look at these. You can remember these 4 graphs. Then what happens there is, oh, hold on, give me a second. Ruben, can you help me out for like 1 or 2 slides?
Yes,
I
ma'am.
need to
No,
get
no,
a snack.
no problem. Okay, so with these 4 graphs that you have in front of you, we can just determine how the behavior of the graph is and how it's going to look. Okay, so the leading coefficient test is going to tell us that we're going to look at the leading coefficient. Now, the leading coefficient is the number that it's associated with the highest degree of the polynomial. So, for instance, x squared. If 2 is the highest exponent, then that is the the leading or that's the degree of the polynomial. So the number that is being multiplied to this variable x squared, that's the leading coefficient. Okay, so if the leading coefficient is a positive number and the degree of the polynomial is an even number, the graph will point upwards. Okay, if the polynomial, its degree is an even number, and the leading coefficient is a negative number or number less than 0, okay, the graph is going to point downward. So the other type of polynomial that we can have is also an odd polynomial, and that's determined by the degree again. Since the highest exponent is a number 3, it's an odd number, so this is an odd function or an odd polynomial. Okay, its leading coefficient here, if the leading coefficient is a positive number, then it's going to keep increasing. And the way that the book states it, it's we look at the end behavior. So for instance, if I go back to my even, the end behavior for an even function where the leading coefficient is a positive number, it's gonna rise on the right and rise on the left. If the leading coefficient of an even polynomial or even function is negative, then the end behavior is going to fall on the left and fall on the right. So now if we jump into the odd function, if the leading coefficient is an even number, okay, it's going to fall on the left and rise on the right. And like again, I like to think of it that's always increasing. Okay, and if my polynomial or our function is an odd function and the leading coefficient is a negative number, again, value less than 0, it's going to rise on the on the left and fall on the right. Okay, and I like to think of it that's always going down. Okay, so this is what's called the leading coefficient test to determine the behavior of our graphs. So let's see, let's look at some examples. So describe the left-hand and right-hand behavior of the graphs of each function. So we have a, f of x is equal to 3x to the 8th power plus 7x to the 2nd power minus 2x to the 5th power plus 4x plus 100. So on the first one, a, what would be the degree of this polynomial? What's the highest exponent that you see for an x? Give a couple of seconds. Okay. So hopefully what we see here is our highest exponent is the 8, okay? So 8, I say to myself, is 8 an even number or an odd number? Oh, 8 is an even number. So hence this polynomial is referring to an even function. So what I'm going to use is the behavior for my even functions. And here we have the examples. So we're looking at an even function. So now let's use our leading coefficient test to determine its behavior. So the leading coefficient to this term, 3x to the 8th power, the leading coefficient is 3. That's a positive number. So hence, since 3 is a positive number and the degree of this polynomial is even, my answer is to this first one. It's going to rise and rise from the left and from the right. Yes? All right, let's look at B. If we see on B, the degree of this polynomial is a degree 3. So 3 is an odd number. So this is an odd function. So now let's use our leading coefficient test to determine its behavior. So the value in front of this x cubed is the -1. So -1, that means for an odd function, we're going to use this last case where it's going to rise on the left and fall on the right. All right, how about C? This one's out of order, so the computer's going to try to trick you. But what is the degree? What is the highest exponent that this function has? And again, we can see that our highest exponent is an 8. So then this makes it an even function. So what is the leading coefficient? The leading coefficient is a -4. So in this particular one, for an even function with a leading coefficient of a negative value, it's going to fall on the left and on the right. Yes? All right, what about D? Our last example. What would be the degree of our polynomial here, or our function? So we can see that our degree is 3, right? So this is an odd function, but we got to be careful. They factored out a -2. So to find out what the leading coefficient is, we would have to distribute that -2 back into the polynomial. So -2 times 1 is going to give me a -2x cubed. So on this particular problem on D, since it's an odd function, it's going to rise on the left and fall on the right. Yes, it's going to be our last example. So I hope understanding the degree of the polynomial and knowing what the leading coefficient gives us a lot of information to describe the behavior and how the graph is going to look and appear. Okay. All right, let's move on.
Hey, Ruben,
Hey,
I'm
Mr. Yukin, do you
back.
want to? Yes, go ahead. I'll give it back to
All
you
right.
again.
Okay, thank you. So the next thing is the multiplicity of a zero, which is going to determine if a zero is going to touch or if it's going to cross. So if you notice here, the graph touches and then it turns, and here it crosses the x-axis. Okay, so if you remember f of x equals x squared, here we can see that the zero, if I was to find the zeros, I actually get x equals 0 and x equals 0. So here we say that the zero, the multiplicity is 2 because it appeared 2 times. And so if it's even, then it's going to touch. But if you look at x cubed, if I was to solve for x, if I wrote it this way, then I see that I get 0 is equal to x, 0 is equal to x, and 0 is equal to x. So this has 3 zeros. They all happen to be the same 0, And that's why we say that the multiplicity of this 0 is 3 because it occurs 3 times. And since the number 3 is odd, then therefore it's going to cross. Okay. So let's look at an example really quick. Find all the real zeros and determine the multiplicity of each 0. So to find the zeros, remember we said and I'm going to try to factor. So here I'm going to factor x minus 1, x minus 1. And if I solve for x, I get x equals 1 and x equals 1. So what is the multiplicity of x equals 1? In other words, anytime you hear that word, they just want to know how many times did that 0 occur. So x equals 1 is occurring 2 times. So that's going to be an even number of times that it occurs. So we say that the multiplicity at x equals 1 is 2, and it's even, so the number 2 is even. And therefore, if we were to graph it, it's going to come, the graph is going to touch the x equals 1, and then it's going to turn. Okay. Here's another one. So if I want to find the zeros, I'm going to set it equal to 0. I can factor out a t. So I get t squared times t squared is t to the 4th. T squared times negative t is t cubed. And t squared times 30 is 30t squared. Now I can factor the parentheses. 6 times 5 is 30. And if I have a negative 6 plus a 5 will give me that negative 1. So if I set these factors equal to 0, I get 0 is equal to t squared, 0 is equal to t minus 6, and 0 is equal to t plus 5. If I simplify, then I get t is equal to 0, 6 is equal to t, and negative 5 is equal to t. So if we look at t is equal to 0, there's actually 2 zeros here because remember t squared, you could have easily written as t equals 0 and t equals 0. So we say the multiplicity of 0 is going to be 2, and that's an even multiplicity. So the graph is going to touch and turn. But for 6, 6 only occurs one time. So for the 0, 6, it's only going to go through it. It's going to cross because it's an odd multiplicity. And negative 5 only occurs one time. So it's going to have an odd multiplicity. And so if you were to graph it, then at 0, it's going to touch. And at 6 and negative 5, the graph is crossing. Okay. So I have about 4 minutes, so I'm going to try to get through this one because at the end, you do have to graph these functions. So to graph them, you're going to identify the end behavior, find the zeros and the multiplicity, find the y-intercept, and plot additional points. So first, let's look at the end behavior. The degree is 3. My leading coefficient is 1. So that means that the graph is going to rise to the right and fall left. So I'm going to just write that there. To find the zeros, I can factor out an x squared. X squared times x is x cubed. X squared times 3 is negative 3x squared. So if I solve for x here, I take the square root, I get x equals 0. And for this one, if I add 3 on both sides, I get x equals 3. However, for x equals 0, the multiplicity of that is 2 because I have 2 zeros occurring there. And then for 3, our multiplicity is 1. So at x equals 0, the graph is going to touch. And at x equals 3, the graph is going to cross. The y-intercept, we let x equal 0. And we solve for y. So in this case, if everything is 0, then we get 0, 0. And then so your last step is to start plotting this information. So I have a 0 at x equals 0 and 1 at 3. My y-intercept is at the same location. And then I'm going to apply the end behavior. Okay. So we know that, and I would encourage you to use a pencil when doing this because you might have to erase a little bit. But at x equals 3, I know that the graph is going to cross. So I'm just going to draw a line through it to indicate that it's crossing. But at x equals 0, I know that the graph is going to touch. So I'm going to kind of draw my graph there. But more importantly, the end behavior tells me that the graph should rise to the right. So therefore, this is why I'm indicating the rise behavior with the arrow pointing up because it's going to rise up this way. And then it's going to fall to the left. So my graph is going to fall to the left and I can indicate it with this arrow going down. Now I need to know what happens in between my graph here. So in order to figure out what's going to happen in between, we need additional points. What points are you going to choose is up to you, but I would encourage you to pick something that's in between. Because if I pick a point over here, then it's not going to be as helpful. I should get something down here, right? But I want to pick something in between. So I'm going to choose 1 and I'm going to choose 2. So if x is 1 and I plug it into my equation right here, okay, then I get 1 squared, and that should be a cube. 1 cubed minus 3 to the 1 squared is equal to -2. And if I plug in a 2, I get 2 cubed minus 3 times 2 squared equals -4. And I actually picked 2.5 as well. And simplify, I get this point. So if I plot these points, here are my 3 points that I picked, then we can see that the graph is, and I connect my points, right? So if I connect my points, then I know this graph will go back up. And so this is just a sketch of my graph. The computer graph, which always looks more beautiful, is going to be this one, okay? But definitely in paper, this is still beautiful, right, guys? All right, cool. So anyway, so just to summarize really quick in the last 40 seconds I have, if you want to graph something, you do have to find the end behavior so that you can know which way the graph is going to be rising and falling. Then you need to find the zeros. So you need to find these points here and determine if it's going to cross or if it's going to touch. And then you do that by looking at the multiplicity. You find the y-intercept as one of your extra points, and you find that by letting x equal 0. And then pick additional points so that you're able to graph your points. So on WebAssign, you'll notice that most of these questions are actually multiple choice. So if you still do these steps and you create your own sketch, then it'll be easier to identify which of the multiple choice answers would be your answer. Okay. So again, if you want a copy of this PowerPoint, just right above my arrow here is a downloadable icon. So you can download it, save it on your computer. And then I do encourage you to watch the recorded sessions because for example, if you need to go back to the factoring session, then that would help. Or maybe your homework, at least for my students, 2.1 and 2.2 for my online classes is due this week. So if they're stuck, then hopefully they can come back and look at some of these examples. But we do have some tutors available. If you have any questions, you can stay here. We thank you for joining us on a Friday and having a great time in our Friday Happy Math Hour. And so next week, our people here from our Student Success Office is going to put up what's going to be happening next week. So I just want to thank you. Mr. Carizales, is there anything you wanted to add?
No, awesome job, Yvette. Great job. Thank you all.
Thank you, Ms. Chuka. Thank you, Mr. Carizales, for your wonderful presentation. We do want to remind you all again about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey and remember to send your student ID number to us before you log out. Ms. Patricia has sent individual messages to everyone to sign you all in. If you would like to download a copy of today's presentation, you can go to the top right corner and click on the box with the arrow going down. That will allow you to download whatever's on the screen. Before you all leave, I want to share the TVE sessions that we will have later today. So for today at 1 p.m., we will have another TVE session called, oh, I'm sorry, I lost it. But it is going to be Rio Grande, new medical building tour. And then next week, we will be back at 11 p.m. with synthetic division and complex numbers and solving exponential and logarithmic equations. Join us again next week. And if you can, join us again for the 1 p.m. TVE. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any